This video is for naming branched and haloalkanes. Now these videos are primarily intended for the students taking my Chemistry 1152. This is a survey of organic and biochemistry, primarily for nursing students. If you're taking organic chemistry for science majors, you may want to find more detailed videos that go into more depth. So if we want to name an alkane, the first thing we always need to do is determine what the longest chain of carbon atoms is. And this is going to provide the base name for the alkane. In the case that there are two identical chains in the molecule, we want to pick the one that has more substituents. Finally, once I've identified the longest chain, I need to decide which end I'm going to start numbering from. And I want to do this so that the first substituent I encounter has the lowest number. If it turns out that there's a tie, then the substituent that comes first alphabetically should get the lowest number. When I then go to name it, in addition to the base name that I determined in step 1, I'm going to name each one of the substituents. I'm going to put those substituents alphabetically. I'm going to give both the number of the carbon atom that's attached to and the name of that substituent. In the case that there's more than one of the same substituent, so let's say there's 2 chlorine atoms attached to my alkane, then I would use the prefixes di, tri, tetra, penta, etc. to tell me how many of each substituent there are. And for example, if I have a tetra, meaning there are 4 of that substituent, I'd have to give all 4 numbers for each one of those substituents. Now, when I'm worried about the alphabetizing, I don't use the prefixes in determining the alphabetical order, right? So for example, in that case, if I had tetrachloro, right, I'd use the C from chloro and not the T from tetra in alphabetizing it. Right, so one of the first things that you need to know is you need to know what the prefixes go with the number of carbon atoms. And so you need to have this table memorized. You also need to know how to name the substituents. Now, the first ones on this slide are pretty easy. If you have any of the halogen atoms, you just chop the end off the name of that atom and add an O. So fluorine becomes fluoro, or bromine becomes bromo. Similarly, if we have carbon substituents, you have to tell me how many carbon atoms there are. So from the previous slide, right, the meth tells me 1 carbon atom. So if I have a 1 carbon substituent, then it would be a methyl group. If I have a 2 carbon atom substituent, it's going to be an ethyl group. Now for methyl and ethyl, there are no other options. When we have alkyl groups of 3 or more carbon atoms, we have multiple possibilities. And so we have to give them different names to distinguish them from one another. In the case of a 3 carbon alkyl group, we can either have a straight chain where the end carbon atom is attached to the base chain, in which case we call that a propyl group. Or again, we've got the 3 in a straight line, but we're connecting through the middle carbon atom, in which case it's an isopropyl group. With a 4 carbon atom alkyl group, there are 4 possibilities. The simple butyl is just a straight chain connected on the end. The sec-butyl, or secondary butyl, is again a straight chain, but connected with the number 2 carbon atom. And then we also have tert-butyl and isobutyl. All right, so let's look at some examples. So the first thing we need to do is determine the longest chain. And so in this case, I think I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we might want to check, sometimes, this looks like the branch, but we want to make sure that I can't make it longer. But in this case, I can just go 1, 2, 3, 4, 5, 6, 7. So this is my longest chain, and it was 9. So that's going to be nonane is the base name. And then I just need to name my substituents. In this case, I only have 1, but I've got to decide which side I'm going to start numbering it from. Right, so if I started here, it would be 1, 2, 3, 4, 5, 6. So this would be 6 methyl nonane. But if I start from the other end, 1, 2, 3, 4, I can make that substituent a lower number. And that's what I want to do. So this is going to be 4 methyl nonane. Okay, so I've got another molecule here. Looks like I'm going to have more than one substituent, but as always, the first thing I need to do is figure out what my longest chain is. And so if I go 1, 2, 3, 4, 5, 6, that would give me a hexane. However, if instead of rather going off to the side, if I continue down here on the chain, I can get 1, 2, 3, 4, 5, 6, 7. And so that's a longer chain, and so this is my longest chain. And then this and this are my substituents. So my longest chain was 7, so that makes it heptane. And then my two substituents, so I've got a bromo and a methyl, but I need to decide which end to start ordering it from. If I start on this end, it's going to be 1, 2, and so my first substituent is 2. If I start on this end, it's going to be 1, 2, 3, and my first substituent would be at 3. And so to decide which end I want to order it from, I want the first substituent to be as low as possible. So I want to start with this one, right? So in my numbering, I'm going to have 1, 2, 3, 4, 5, 6, 7. So then this is 2 bromo, this is 5 methyl, and I put these in alphabetically. So the B in bromo comes before the M in methyl. So this is going to be 2 bromo, 5 methyl heptane. And so just another note, if you notice, in between each part, so in between each number and each substituent, I put dashes, except the last substituent can go right into the base name. So I've got 2 dash bromo, dash 5 dash methyl, and then the methyl can go right into the heptane. Okay, so the first thing we have to do is find the longest chain. So I have 1, 2, 3, 4, 5, 6, 7. All right, and that's the last carbon. Or I could go 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 3, 4, 5, 6. Looks like 7 is my longest. So my base name is heptane. All right, and when I decide which end to start ordering from, if I start on this end, it'll be 1. My first substituent is at 2. But in this case, my first substituent would be at 1. So this is the end I want to start numbering from. So I have 1, 2, 3, 4, 5, 6, 7. All right, so this is 1 fluoro. This is 6 fluoro. And this one is 4 ethyl. So the E in ethyl comes first. So I'll start with 4 ethyl. And then I have 2 fluoro groups. So this is where I'm going to use the difluoro. So I got to give the number for each one. So it's 1, 6 difluoroheptane. So it's 4 ethyl, 1, 6 difluoroheptane. Remember, when I did the alphabetization, right, I compare the E to the ethyl to the F in fluoro. I don't use this prefix in determining the alphabetization. All right, my longest carbon chain, 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 identical chains. It doesn't really matter which one I pick. I'm going to get the same name either way. So I'm going to go with this as my my base chain. So that was 8. So that makes octane. All right, I want to start numbering from this end as opposed to this one, because this gives me 1, 2, 3, 4 for the substituent, whereas this one would give me 1, 2, 3, 4, 5. And then my substituent has 3 carbon atoms. So there are 2 possibilities. This could be propyl or isopropyl, but because I'm attaching to the end, right, this is my propyl group, right, because I'm attaching to the end of it, that just makes it the regular propyl. So we said this was 1, 2, 3, 4. So this is 4-propyl octane. All right, the next one shows the other type of propyl group. All right, so this is a very similar molecule. I still have 1, 2, 3, 4, 5, 6, 7, 8. My substituent's coming off the 4th carbon, and it's still a propyl, right? It's still 1, 2, 3. But now rather than attaching to the end carbon, I'm attaching to the middle carbon. So that's what makes this isopropyl as opposed to propyl where it was attached here. So this is going to be 4 isopropyl octane.